record. Okay, I almost forgot again. Earlier this morning, I got cut off from Zoom. No, I checked my internet. It's okay. So I also had I experienced a little slowing down from Zoom. No, earlier before I logged in. So anyway, you may get cut off. You just go back. Okay. So and then we are going to continue discussing K mapping. No, and then the exercise is up there. You can start writing the K map. You pass the solution in Excel form. Okay, Villar Luares. Okay, the solution in Excel form. I'm going to give you examples anyway. No? So meron na tayo, we have these theorems. No? What's this assignment? Petrick. No? Later we will discuss Cohen-McCluskey and Petrick's method. These are variations of Cardinal. These are variations of Carnot mapping, no? Which can be programmed in a computer. No? Do you follow? So the problem with K mapping is it's hard to program. In fact, nowadays, if you search in Google for Cohen-McCluskey and Petrick's method implementation in C#, obviously you can find them. No? So let's go back. No? So we know how to create the K map. No? So for a two variable K map, we distribute one of the variables in the columns and the other variables as rows. No? For example, we designate the variable A to be our row and the variable B to be our column. Okay. So we start for our row, we start with not A and we proceed with A. This is not a binary series. No? How you generate the next row is see to it that the next value is 1 bit different. No? 1 bit different. So we only have 1 bit. So A is 1 bit different from not A. You start with 0 always. No? And not B, we start with not B and the next is B. It's 1 bit different. Now for this function, we have AB. So this is AB. This is square AB. We have it marked with one. And we have not AB. We mark this with 1. All the rest we mark with zeros. Okay. That's what we do to create the two variable K map. Okay. For a 3 variable K map, we assign 2 variables is in the rows and 2 variables, 1 variable in the columns. No? Or we can do it the other way around. 2 variables in the column, 1 variable in the rows. It's the same thing. Okay. So for example, we have the function y is equal to ABC plus not A, BC plus not A, not B, not C. Okay. So we construct the K map. We start with not A, not B, 0. Not AB. So not AB is 0, 1. So by the way, AB is 1, 1 because we cannot start with 1, 0 because 1, 0 is 2 bits different. Do you follow? So hindi pwede itong A, not B dito. We only have AB and the remaining is A, not B. This is 1 bit different also from the previous. Okay? Take note, no? Not AB and AB are different in A, but they're the same in A and B. Now, if you put this above, no, if you interchange places, that would be wrong because they're different in both A and B. So not A and B, not A and A are different. B and not B are different. Unlike here, we have not A and A, they're different, but B and B are the same. So we have A and A the same and B and not B different. It's okay because it's only 1 bit different. Okay? Any questions so far? So I got, hello, can you hear me?
Yes, sir.
It got cut off again, no? So this is the second time I got cut off. I'm glad you did not go away, no? I got cut off. This is the second time I got cut off. Only from Zoom, no? Maybe the Zoom server is getting overloaded, no? Overloaded with so much. So take note, no? AB, one bit different. The next row should be one bit different. I think the recording is still okay. It did not cut off, no? Okay. So, now for the columns, we start with not C. So, and then the next column is C. They're one bit different. Okay. So we have ABC. ABC is what? ABC. So we mark this with 1. Okay. The next term is not ABC. So we have not ABC. So we mark this with 1. Okay. The last term is A, not B, not C. A, not B, not C. So this is the cell. We mark this with 1. All the rest we mark with zeros. Okay. So 4 variable came up. So ganun din. Now this time we assign 2 variables in the rows and 2 variables in the columns so that they're equal. So we'll have a square row rather than a long grid. No. So we have this. No. We start with not A, not B, not A, B. They are one bit different. Remember that not A and not A are the same, but not B and B are not. So it's okay because they are only one bit different. And then we have AB. So B and B are the same, not A and A are not the same, so one bit different. And then A and not B, okay? And then we have not C, not D, not CD, one bit different, only in D. And we have CD, one bit different, only in C. And C not D, one bit different, only in D. And then we write the entries into our grid. A not B, CD. A not B, CD. It's this, so we mark this as 1. Do you follow? And then AB, not C, not D. AB, not C, not D. So this one we mark as 1. And we have A, not B, not C, D. A, not B, not C, D. This one, so we mark. Okay. And then we have not A, B, not A, B, C, D. So this one we mark. And the last one is not A, not B, C, D. Not A, not B, C, D. We mark this. Do you follow? That's how we do it. No? And then we look for groupings. Okay. In here we are trying to study the groups in terms of the smallest group to the highest group. But in actual problems, no, we will be starting with the biggest groups. No. So the first group of ones that you can find is the pairs. Now the pairs can be vertical and can be horizontal like this. Diagonals are not allowed. Okay, hindi pwede diagonal, no? Make sure, no? Diagonals are not allowed. We'll do a slideshow, better slideshow. Diagonals are not allowed. Okay, the next is quads. No? A quad can either be vertical, 4 ones, and horizontal, and they can be square, like this, no? Square pwede. Okay, quads. And then octets. Octets are groups of 8s. No? They can be horizontal and vertical. Can we have a square octet? No. We can't have a square octet, no? Problem, quads lang. Okay. Now we can overlap groups like this, no? In this group we have octet 1, O1, and we have P1. This is valid. Okay. We have a pair here and we have an octet here. Do you follow? Redundant groups. Redundant groups are groups all of whose members overlap with other groups. Like in this case, we have 3 pairs, P1, P2, and P3, right? And P2 is a redundant group. Do you follow? Why? Because one of its members belong to P1 and its other member belongs also to P3. Okay, so redundant. Like in this case, if you make a quad inside an octet, that quad inside the octet is redundant. Or you make a pair inside the octet or a pair inside a quad, fully inside a quad, that would be redundant. Okay, any questions? So redundancy, no? Rolling the map. Now you see, we can roll the map because the left end of the map and the right end of the map are one bit different. Take note, they're also one bit different. Now, the first row and the last row are also one bit different. Do you follow? So we can roll them up. So in this case, we can, instead of making up 2 pairs, we can make a quad. Okay, we can also make a pair here. Do you follow? By rolling them up. Any questions so far? No? How do we simplify functions? No? Create the grouping starting with the largest groups. Given a K-map.
Earn faith. Yung panalo, Dad. Yung cake, yung...
Okay. Okay. How do we simplify a function? Kasi ang hirap, no? If we are going to simplify functions using brute force, no? Using mathematical algorithms, using Boolean laws, we become mathematicians, no? We become bright and intelligent, smart mathematicians, but we don't intend to be mathematicians, okay? We intend to be programmers and designers, okay? So we make use of K-maps. But if you do, the object is like this. If you do it in Boolean algebra, you will have the same output if you do it using K-maps. Okay? Do you follow? Do you follow? So first, given a K-map, you create the groupings starting with the largest groups. Always apply overlapping and rolling. No? Always apply overlapping and rolling. The better overlapping, the better rolling you have, okay, the simpler circuit you will get. Okay, the simpler expression you will get. Eliminate all redundant groups. Never include redundant groups. Okay. For each group, write the term removing the variables that have been complemented. Okay, we'll look at that. No, which variables are complemented. If they are complemented, we remove them. And then write the new SOP by adding all mean terms. Okay. Any questions so far? Okay. So for example, we have this K-map. No? If you look at this K-map, right, you'll have 4 quads. Q1, this is Q1. This is Q2. This is Q3. And you will have P1. Do you follow? Do you follow? Now, Q1 is not redundant because it has this square which does not belong to any other. Q2 is also not redundant because it has a square which is unique to itself. Q3 has a unique square. P1 has a unique square. You cannot make a pair inside here because it belongs to somewhere. No, it belongs somewhere else. No, redundant siya. Okay? Do you follow? No? We'll look at the 2 slides. No? Dapat hindi na tayo naka-slideshow. It's like this. No? Look at P1. This is P1. Okay? If you look at P1, we have CD. Okay? You have A not B and AB, right? The coverage of P1 will be this, will be CD, A not AB and AB. Now, there are 3 terms, A not B, AB, and CD. Which variable is complemented? CD is not complemented. B is B, not A, and A is a complement. Okay? Therefore, for P1, we will only retain BCD. So, no? For P1, BCD lang. Do you follow? Any questions? No? For P1, BCD lang. Right? Now, let's proceed to Q1. The bigger the group, the simpler, no? The simpler the expression. Q1, for Q1, let's look at Q1. Q1 involves AB, AB, right? C, not C, not D, not C, D, C, D, and C, not D. So if you look at Q1, AB, only A and B are uncomplemented. Not C is complemented by C. Not D is complemented by D. So if you take a pair, you can remove 1 variable. If you take a quad, you can remove 2 variables. So that's why we start with the bigger groups. No, when we make groups, we start with the bigger groups because you can make simpler expressions because you can remove more variables. Okay, so it's here now. So you will remove CD. So for Q1 we only have AB. That's why we have here no AB. Okay. For Q2, this is Q2 quad 2. So we have AB, A not B, not C not D, and CD. Take note, not C and C is a complement. No, D and D is not. And you take a look, B and not B is complement. So therefore we can remove B and C. So therefore for Q2 we will only have AD. Arellano is in the waiting room. Paano ba ito? Arellano? Okay. Si Dwight. Kisa mo si Dwight gani? Anyway, this is recorded, no? Dwight. Jesus. Okay. Let's go back. For Q3. For Q3, we have A, B, and A not B. Ito, Q3. Ito, A, B. So not B should be removed. And we have C and C not D. So not B and D should be removed. So we'll have AC. Okay? So ito yon. For P1, we have BCD because A is removed. For Q1, we have C and D removed. So we have AB. For Q2, we have this. And then we add all these terms together so that we will have P1 plus Q1 plus Q2 plus Q3. So we have BCD plus AB plus AD plus AC. Do you follow? So the resultant circuit requires one 4-input gate or gate kasi 4 input ito. 1, 2, 3, 4. Okay, 1 3-input AND gate. Ito 3-input AND gate. And 3 2-input AND gates. And the wires you need are 13 wires. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Do you follow? The wires you need to interconnect are 13 wires. Okay? So this is much simpler if you have this. The original expression. Kapag ganito, ilang AND gates? You will need 1, 2, 3, 4, 5 AND gates. 4 input AND gates. Okay? You will have 1, 2, 3, 4, 1, 4 input OR gate. And how many wires you need? 1, 2, 3, 4, 5. Kasi yung OR gate. And then 1, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 wires. No? 26 to 13 wires. There's a big difference. Do you follow? No? So by gate leads, we mean how many wires do you need to construct the circuit? Okay, you can imagine that already. You construct it in Sidor logic and count the connections. Do you follow? Now, sometimes there are don't care conditions, which means if they don't matter. Okay, don't care conditions means those are not included. For example, if you have 1 to 16 values, no, A, B, C, D, and only the 10, the 0 to 10 are used, the 5 are not. Okay, so yung 11 to 15 or 10 to 15 will be don't cares. So we mark them as X. Now the good thing about don't cares is they can be used to make larger groups. So you can make a pair like this and we can make a quad like this. Can we make a quad like this? No, you cannot make a quad with all don't cares. No, at least the group should have one which is not a don't care. Okay, do you follow? Okay, so any questions so far? So now you have an assignment. Okay, I think some of you have solved this already, but we will discuss this next meeting. Okay, so my assignment tayo dito. This is the assignment. K mapping 314 and 321, page 79 and 80, no? Paano ba to? Bakit hindi siya mag-submit? Let me turn my... Hanggang September 24 pa naman, no? Bakit ayaw? Okay. Nandito na rin yan, okay? I also have written it here anyway, no? So wala pala. No attempt yet. You solve this, okay? Using the example 79 and 80. Let's look at that, no? 3-14 and 3-21. Okay. Naputol pala yung aking ano. First, anyway, we'll upload the second. Okay, we'll upload the second. No? We recorded this anyway. Yes. Okay. Page 79 and 80. Three dash 14. Ito, no? And 3-29. At nandito na yung 21 sa iba, no? Do you follow? Okay. Do you follow? We'll discuss this next meeting. Questions? K-mapping ito, no? K-mapping lang gamitin natin, no? I'm sorry, mali. 79 and 80. Bakit mali, no? Let me look at that, no? 3-14 and 3-21. Mali yung 21. Ano, you can still do 21 using K-mapping, okay? Don't use the consensus theorem. Okay? Do you follow? Ano ba yun? 3-14 pala, hindi 3-19. Okay? 3-14 and 3-21. Okay? Okay, can you solve this yourself? No? And then we'll solve this next meeting and we'll introduce a new process called Quine-McCluskey. Any questions so far? No? And then construct the circuit. Try at least to construct one circuit in Cedar logic. Okay? Okay. And then take note, no? After this, we will have experiments. No? You will have experiments. Ano ba yung last experiment natin? 2 and 3. Can you do experiment 4? No? Experiment 4 in Cedar logic. Dito. Experiment 4. What is encoders? No? Encoders. Okay. Experiment 4 and 6 lang tayo. No? Experiment 4 is encoder. This is used in a keyboard. Have you submitted this already? Okay. Meron na pala, no? Experiment 4, have you submitted this? You just submit this, no? Hindi na ito groups by ano na ito. Let me just open this up. Can you submit this next week? experiment 4. You need to group. Experiment 3 and 4 na lang, no? When should be that 27. Yes. Sabay na lang ito, no? September 27, experiment 3 and 4. Experiment 3 is not a group. 2 and 3. Tapos sa pala tayo sa 3, no? So we'll not do 3 anymore. We'll hide this. Only experiment 4. Individual na ito, no? Consider logic, no? September 27. Okay. Experiment 4 lang. 3 tapos na tayo. Okay. Any questions? So you solve the exercise 3-14 and 3-21. And then you do the experiment for next meeting, okay? We'll discuss that next meeting, no? Ang ano, K-mapping exercise. Okay, that's all for now. Class, no? Thanks for coming. Let's not force things up. No? We'll have 2 very complicated topics coming. That's Quine-McCloskey and Petrick's method. Okay, any questions? So we'll end the session now. I'll upload this. I think I have a significant portion to upload. Thanks for coming, everyone. Okay.
Thank you, sir.
Yes, sir.
See you next Thursday, okay?